When we graph a quadratic function, we get a distinctive U-shaped graph called a parabola. If a quadratic function's in standard form, that's our ax squared plus bx plus c equal f of x this time rather than equal 0. We can plug in points for x, plot points, graph, and what we're going to see are one of these two general shapes. And you may remember this. If the leading coefficient at the value of a is positive, we'll get a parabola that opens up in a smile. And if the leading coefficient, the a value, is negative, then we get one of the upside down parabolas in a frown. Some more vocabulary. The point where the graph turns around is called the vertex. So this point here would be the vertex of this parabola. And that is going to be a point, so it's going to have an x-coordinate and a y-coordinate, which we usually call hk. And of course, this would be the vertex of that one. The vertical line that cuts the graph into two identical halves is called the axis of symmetry. It's a vertical line, so its equation is going to be x equal h, where h is the x-coordinate of the vertex. So the axis of symmetry is going to go right through the vertex. If we're graphing on a calculator, what I'd like you to do, grab your graphing calculator and put these three functions in. It's y1, y2, and y3. So y1 equals x squared, y2 equals x squared plus 2, and y equals x squared plus 5. Go ahead and graph those three. And I'm hoping you're looking at a much neater graph on your calculator than what you're seeing here on the screen. But what you should have is the basic graph x squared has its vertex right at the origin 0, 0. And the line, the function y equals x squared plus 2 should have its vertex here at 0, 2. And the third one, x squared plus 5, should have its vertex at 0, 5. Now take those same three functions and go to your calculator, switch all the pluses to subtracts, and graph these three. Y equals x squared subtract 2, and y equals x squared subtract 6. Sorry, subtract 5. Okay, so looking at these three, we have again the black line here is the basic y equals x squared. Then y equals x squared subtract 2 has its vertex at 0, negative 2. And the third one, y equals x squared subtract 5, has its vertex at 0, negative 5. So all three of these graphs have the same basic shape, but what we've done when we subtracted a value from the basic function, it shifts the graph down. Whereas when we added a value to the basic function, we got an identical graph but shifted vertically upwards. So in general, if you have a graph x squared plus k, k may be a positive number or a negative number, what you're going to get is the graph of y equals x squared shifted vertically, or up or down, k units. So positive 5 units or negative 5 units, but shifted up or down a value equal to k. And then the vertex will be at 0, k. And the axis of symmetry will still be the y-axis, y equals 0, or y-axis. Did I say x-axis? I meant y-axis. So from that piece of information, if we're trying to graph a function x squared plus 32, we know it's going to be our basic graph shifted vertically up 32 units. So it's going to be way up here. And if we don't know that it's going to be shifted up there, so that vertex is at 0, 32, if our graphing calculator is on a basic window, we're not going to see a graph at all. We're going to have to set the y max on our calculator to be something like 40 or 50 in order to see where the graph is. So knowing what a function should do will help us a lot with the graphing calculator in setting an appropriate window. So a little bit of a variation. This time we're going to go inside and modify the x value before it's squared. So go ahead, grab your calculator, put these three into your calculator, and graph all of them at the same time. So y1, y2, y3, hit the pause button. Okay, got those graphed? So again, what we should see, our basic quadratic with its vertex at the origin. The x subtract 2 squared should be shifted over sideways this time rather than vertically, so a horizontal shift, and its vertex is at 0, 2. And the y equals x subtract 5 squared should be shifted horizontally also with the vertex at 0, 5. Now, I'm going to do the same sort of thing. We've got those three in your calculator. Go back and change all the subtractions to additions and graph these three. I think you're going to notice something that's going to seem a little odd. Okay, so again, we've got a horizontal shift, but the x plus 2 shifted left, so its vertex is at negative 2, and the x plus 5 squared shifted left also, so its vertex is at negative 5, which I think most people find seems a little backwards, that the x subtract a constant shifts right, whereas x plus a constant shifts at left. So the way we make this make sense is we work with x subtract h squared. And that way, if we have x subtract 2, the graph will be shifted 2 to the right, and x subtract negative 2 is x plus 2, and that's how we get our shift to the left. So this would be shifted horizontally h units. The vertex is going to be at h0, and the axis of symmetry is going to be x equal h. So again, a vertical line right through the vertex. And so, again, the sign change sounds a little weird. So if we have, say, f of x equals x plus 10 squared, what we want to do is think of that as being x subtract negative 10 squared. And the vertex will be at negative 10, 0. Okay, putting these two ideas together, we get the formula for the equation of a quadratic equation in vertex form, x subtract h squared plus k. So if we have it in this form, the vertex will be at hk, and the axis of symmetry will be at x equals h. And quick example here, f of x equals x plus 2 squared subtract 3. This will give us x subtract negative 2 squared subtract 3. And so a vertex will be at negative 2, negative 3. Okay, those are all what we call rigid transformations. They don't change the shape of the parabola. And we're going to look at some that are actually going to change the shape of the parabola. It'll still be the U-shaped graph, but it's going to make it a little taller or a little shorter. So grab those calculators again. We'll have our basic x squared, and then 3 times x squared and 0.25 times x squared. Go ahead and graph those three. Okay, so the red line here is going to be the 3x squared. The black line is our y equals x squared. And hopefully you have a better looking graph on your calculator in front of you. When we multiply x squared by 3, what we've done is made the graph taller. So every y value is 3 times as tall as the original y equals x squared function. So if we multiply x squared by a value of a, if the a value is bigger than 1, we get a taller graph. A lot of students like to think of this as being a skinnier graph, but mathematically it makes more sense to think taller because we've got a y value 3 times as tall as the original one. And then if we multiply by a number that's a fraction, something smaller than 1, then the graph is a fractional as tall as the original one. So for any given value of x, the green line is 1/4 the height of the black line. So when we multiply by a value of a between 0 and 1, we get a graph that is shorter. Now we know that if when a is negative, the parabola is reflected over the x-axis. We get one of those upside down frowny parabolas. And so if we combine that idea with the idea these values be multiplied by constants bigger than 1, smaller than 1, if we multiply by a value smaller than -1, so say it's something like -2x squared, -3x squared, we'll get a parabola that is both taller but also flipped upside down. And then if we multiply by a negative value that's a fraction between 0 and -1, the graph will be both upside down and shorter. The fraction is tall. Okay, so putting all three of these together, if we're graphing a times x subtract h squared plus k equals f of x, left that off, we've got the vertex form of a quadratic equation. So without even touching our calculator, we know quite a bit about what this particular function should look like. We know that it's been shifted horizontally 2 units. We know it's been shifted vertically 3 units. So its vertex is actually going to be at 2, 3. The -1/3 here tells us two things. Because it's a negative value, it's going to be flipped upside down. And because we're multiplying by a fraction, it's going to be a short function. Or wide, if you want to think of it that way. And so I can make a rough sketch of the graph just from looking at the equation. I know the vertex will be at 2, 3. It's going to be upside down, and it's going to be kind of a wide graph. Go ahead, put it into your calculator and compare. I'm sure it will look much nicer than what I just drew here. But again, should have the vertex at the 2, 3, flipped upside down, and a graph that's on the y side.